this is going to be our last section for this quarter. This will be the last thing that you see on the test, and then we'll pick up with the rest of chapter 6 after this. Okay? Multiplying polynomials. So we're going to be using and applying the laws of exponents with multiplication, but now it's not as simple as just looking at everything and just kind of applying the rules for everything that we see. There's going to be some additional steps added in. All right? Now, when we're multiplying monomials, it's lucky there's not a whole lot different there. Okay? We've been doing this process of multiplying the monomials and just multiplying our coefficients, adding our exponents, or subtracting our exponents. A lot of you are still getting messed up when we have negatives here. Remember, a negative coefficient is just a negative coefficient. It doesn't move a variable from one side to the other, only if we have negative exponents. So I want you guys to keep that in mind. I still see a lot of negative exponents becoming negative coefficients moving to different places. They're just coefficients. So multiplying our coefficients together, 3 times negative 2 gives me what? Negative 6, okay? It's not going to be 1 over 6. It's just negative 6, okay? And then if I have x squared times x, what do I end up with?
3.
X to the third, okay? Nothing different there. Same thing with our monomials. Okay, well, what's my coefficient on x right here when I have that negative?
What
do you mean? Remember, it's 6 times y to the third times z to the squared. They're distinct. They're distinct. So I can still multiply those together. Because my commutative property of multiplication, all of this stuff is being multiplied. So I can multiply it in the order. Don't touch it. The x will stay the same. So I've got 6 times negative 1. And then I've got x. And there's no other x, so it's just x. Okay? Y to the third times y to the fifth. Y to the what? Y to the 8. Add your exponents. Z squared times z to the fourth. Good. Okay? Nothing new there. Right? Okay? Multiplying, applying those properties. Now, I've got some addition and subtraction added in. Okay? Multiplying polynomials is just distributive property. Now, depending on the complexity, there may be some combining like terms added into it. Okay? But it's just distributive property. So every term in the first polynomial will be multiplied by every term in the second polynomial. And just simplify. Okay? Say that again. Every term in the first polynomial will be multiplied by every term in the second polynomial. That's what distributive property is. I'm going to take this. I'm going to multiply it by 3x squared. I'm going to multiply it by negative 2x. I'm going to multiply it by 5.
Right, okay.
Okay? So if I have 4x squared times 3x squared, what's that get me? 12x to the fourth. 12x to the fourth. And now I have to do 4x squared times negative 2x. Yep. Negative 8x
3
to the third. Good. And then 4x squared times 5. Not third. Nope, because 5 doesn't have an x. So it's just the 5 times the 4 and the x squared stays. Okay? Just distributive property. Everything in the first gets multiplied by everything in the second. Alright? Now, let's add some more stuff to it. It's still just distributive property. Can you go back for a second? Plus and minus signs? No plus and minus signs. So this, we're multiplying. I'm multiplying this monomial by this monomial, but it's just 2 monomials. Now I have a monomial and a trinomial. So the monomial gets multiplied by every term in the trinomial. but I'm not multiplying any of these terms together because these terms are being added and subtracted. Yeah, because it's what we're going to add. We're going to add in the combining like terms with the multiplying on the next. Okay, so monomial times a trinomial, we just distribute and then we're done. But when we add in non-monomials for our multiplication, so we're still going to do distributive property, okay? And again, we are multiplying each term of our first one by each term in the other, okay? So distributive property. Now I'm just going to get out of the way. Who's heard of the term FOIL? Okay, if you have, that's what we're doing. I'm not going to bring it up again because it only works with binomials and we're not doing just binomials. But that's the idea, okay? So I'm going to take this 2x, and that 2x is going to be multiplied by everything in the other polynomial, the 7x and the 5. I'm also going to take the negative 4, and I'm going to multiply it by 7x and 5. So everything in the first gets multiplied by everything in the second. Yes, ma'am? So what we'll do is we'll combine like terms. So let's do the multiplication and then we'll see how we clean it up from there. Okay? So let's start with 2x times 7x. What does that give me? 14x to the second. 14x squared. And then 2x times 5. 10x. Okay? Now let me change back to my blue. Okay, now, so 2x got multiplied by everything. Now I'm switching to the next term. Negative 4 times 7x. Negative 28x. And then negative 4 times 5. Negative 20. Now, since I had to do distributive property with more than one term, now I have to simplify. Do I have any like terms in my result? So I just need to combine those. So 10x minus 28x gives me what? 10x minus 28. Do I have any other like terms? Then we're done. And then you just write your polynomial in order of descending powers. Okay? Highest degree all the way to the lowest degree. 2, 1, 0, 4, 5, 4, 3, 2, 1, 0. Whatever the highest polynomial is, whatever the highest degree term is, you start with that and you work your way down. If you have more than one variable, after you do order of descending powers, it's just alphabetical order. X times x is x squared.
Okay, all right.
Because remember we got x to the first, add them.
Right.
Okay. Any other questions? So no matter how complicated it gets, this is what it breaks down to. Distribute each term with the first to everything in the second. So, binomial, trinomial. What am I going to do with A? So I'm going to multiply A by all three terms. Okay? So do it. A times A to the third. A to the fourth. Times negative 3A squared. Good. Times 7. Okay? What's next? Same thing with 2. 2 times A to the third. 2 times negative 3A squared. 2 times 7. Okay, am I done? Let's see if there's any like terms. And we want to simplify them. Okay? So does A to the fourth have any like terms? No. So we're just going to rewrite it. Does negative 3A to the third have any like terms? With what? And it simplifies to give me Close. Negative 1a to the third. Okay? Now, I want the next highest power, so I'm going to go to squared. All right? Does negative 6a squared have any like terms? Nope. So we just write it. Now I can go to 7a. Does it have any like terms? Nope. Does 14 have any like terms? Nope. There it is, and in order of descending power, 4, 3, 2, 1, 0. All right. Multiple variables. It's fine. Same thing. Multiply. 3x times 7x. Good. 3x times 2y. 6xy. 6 times x times y. Right? Negative 7y times 7x. Yep. Negative 49xy. Note how these are in alphabetical order. Whether you're doing x times y or y times x, just write it alphabetical order. Okay? Alphabetically. If you have multiple variables in a single term, just write it alphabetically. Because it also makes it easier when you have to realize that you need to combine like terms. As long as everything's in alphabetical order, it's easier to make those connections. Because a lot of times you might think that xy is different than yx, but it's not. They're the same term. They're like terms. Okay? And then negative 7y times 2y. Good. Negative 14y squared. Do I have any like terms? Yep. What are my like terms? 6 and the negative 49, which combines to give me what? So I have 21 x squared minus 43 xy minus 14y squared. Okay? And that is the proper order that these need to be written in. Okay? So let's take a look at descending powers in standard form of these polynomials. Okay? So this is our proper notation. I want to point something out. What is the degree of this first term? 2. What is the degree of the second term?
1.
It's also 2. What's the power on the x? What's the power on the y? What's 1 plus 1? 2. When you have more than one variable, you add their degrees to get the degree of the term. Okay? And then what's the degree on the last term?
2.
So they all have a degree of 2, right? Okay? So based on degree, they can go in any order. So since we have to figure out what order they go in, we go alphabetical. X comes before y. So the term that only has x, the term that has an x and a y, and then the term that only has a y. That's your alphabetical order. Okay? So highest degree to lowest degree, and if you have multiple terms with the same degree, you order them alphabetically. Okay? Highest to lowest, and then alphabetical. That's the order, and that should cover all cases. Alright? Cool. Now, here's the fun part. Yeah. I think it's fun. But I'm also a sociopath, so, you know. You get what you get. What does it mean when I'm squaring something? Sebastian? Multiply by itself. Okay? I need you to remember that. Like, if you get a tattoo of squaring something and multiplying it by itself, I'll allow it. Yeah. Depends on whether there's parentheses or not. I can give you an example on that later, or if it comes up. Squaring is multiplying by itself. You do not distribute with exponents. I don't want you to get this confused with power rule. Okay? So, example with power rule. All right? 3y to the third squared. What does my power rule say I should do with my exponents? I multiply the exponents, okay? And this is the reason I steered so far away from saying distribute, because we don't distribute, okay? Because I don't want you to think we distribute here. We do not. This does not equal 3 squared plus 4 squared. It does not. They are not the same. They are completely different, and I'll prove it, okay? Squaring is multiplying it by itself. So if I have power rule, if I'm multiplying it by itself, okay, I'm adding my exponents. Okay, I'm just adding the same thing. That's what multiplication is. I'm adding the same thing over and over and over. Okay, power rule gives us a little shortcut for that. But it doesn't work once we add in addition or subtraction, because it's not a power rule. Power rule only works for a monomial. When I add in a binomial, I need to remember, okay, I'm multiplying something by itself. I'm multiplying 3x plus 4 times 3x plus 4. So I have to distribute each term in the first by each term in the second. If I just apply the square to the 3x and the 4, then the only thing I'm multiplying is these. Is that how I did any of the previous problems? I just multiplied two things together? No, I did everything together. So I'm not going to end up with 3x squared plus 4 squared. I'm going to end up with 9x squared plus 12x plus 12x plus 16. If you distribute the squared, you're missing those middle two terms, which will simplify and combine. What's 12x plus 12x? 24x. So 9x squared plus 24x plus 16. Start, highlight it, circle it on your notes, something. Make note of that, because that is a very, very common mistake that I continue all the way through pre-calculus. In calculus. I've seen calculus students do it. Make a note of it. Star it, circle it. Tattoo it on the back of your hand. Something. You cannot distribute that exponent. You square it, you multiply it by itself. Now, when we get into the factoring, there's some shortcuts, some things that I'll show you with special case products that make it a little bit faster. But that's what the process is. Okay? We're going to do the same thing here. 5x minus 2z times 5x minus 2z. So what's my first part? Close. 25x squared. 5x times 5x. Then what? Minus 10xz. Nine minus 10xz again. Any like terms? 25x squared minus 20xz plus 4z squared. Squaring is multiplying it by itself. Do not distribute exponents. This is functionally different from power rule is a shortcut of multiplying something by itself. It only works for monomial raised to a power. We can apply the power. Any other polynomial, we cannot apply that rule. It is distributed, multiply, 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 multiply. So then come on. Trinomial. It's long, but it's the same steps. Now, Once we start getting these longer ones, there's a little trick to make combining like terms easier, which I encourage you to do. You don't have to. If you want to write everything out in a big long line like you did here, that's fine. You can do that. Okay? But if you want to make combining like terms a little bit easier, what we can do is kind of layer as we're multiplying. Okay? So we'll do our first set of distributive property. 2x to the fourth plus 6x to the third plus 4x squared. Okay, keep that in line. Right? Now we're going to do the second set of multiplication. So we already did 2x squared. Now we're going to do x times everything. So x, and x. So I'm going to get x times x squared gives me x to the third, right? Write it underneath 6x to the third. X times 3x gives me 3x squared. X times 4 gives me 4x. So when you have those powers that match, just line them up underneath. And it kind of groups everything for you for your combining like terms. And then we'll do the last set. Negative 1 x squared, negative 3x, negative 4. And then I've got like terms already queued up and ready to be combined. 2x to the fourth has nothing. 6x to the third plus x to the third. 7x to the third. 4 plus 3 is 7 minus 1 gives me 6. 4 minus 3 gives me 1. And then negative 4. And then everything lines up, and it speeds that process up a little bit, and you're less likely to miss something, especially when we get those trinomials and the trinomials, or a binomial and a 4-term polynomial. Once we get those longer things, it makes it a little bit easier to keep track of those like terms, and then we can just add vertically. Not so bad. Now, next thing I want to talk about is special products. These are kind of optional. They're optional now, but they won't be optional later. Okay? Special products are things that are going to show up. Yeah. Ignore. Special products are things that are going to show up later in the chapter, next quarter, when we start doing factoring. Because they're things that are going to show up that you have to know the special products in order to kind of work backwards and do the factor. So when we squared our binomials, there's a pattern that showed up where we ended up with our first term squared, our second term squared, and then the product of the two terms doubled. Okay? That's what this middle term is. The product of the two terms doubled. So I'm going to go back to this slide here and show and highlight. Actual highlight. All right. 3x squared is what? If I have 3x times 3x, what do I get? 9x squared, right? And if I have 4 squared, what do I get? 16. And then last but not least, if I multiply 3x by 4, what do I get? Double it. So, depends on how you write it. And I'll show you how the other way that you would write it. This is going to come in really handy when we start factoring and when we get to perfect square trinomials. And that's what this is called. Okay, we have a special name for this. Okay, so this is called a binomial squared. Binomial squared. When we expand it, it gives me a perfect square trinomial. And when we get into factoring, we'll need to be able to recognize back and forth going from a perfect square trinomial gives me a binomial squared. Okay, perfect square trinomial factors to give me a binomial squared. So that's one of our special case polynomials. Square of a binomial gives me a perfect square trinomial. when we have the product and the product of a sum and difference of two terms, okay? The same two terms. We haven't done one of these yet. The same two terms, but we have added and subtracting. It gives us a difference of squares, which again is a special case polynomial, which when we need to factor this, you can't do it unless you know that connection. You can't do it. All right? You can, but it takes a lot more mental gymnastics to get there. Okay? So knowing the difference of squares is almost essential for factoring a difference of squares back into a product and sum of difference of two terms. So we got to know these special products. All right? So a binomial squared, if you want to do that shortcut with the binomial squared, remember that it's a squared, okay? It's either going to be plus or minus, and it's going to match this term, 2ab plus b squared, okay? What is a in that binomial? Yeah, what is a? Our value for a? X, okay? What's x squared? X squared, right? We square x, we get x squared, okay? So, I can do x squared. What's b? Square it. Okay? Multiply them together. What's x times 6? What's x times 6? 6x. Double it. 12x. Negative 12x. Square the first term, square the last term, multiply double. Square the first term, square the last term, multiply double. So, a was x, b is negative 6, okay? And if I take this right here, okay, I can leave it as plus. I have a is x, b is negative 6. I just kind of sub that all in. X squared is just x squared. 2 times negative 6 times x gives me negative 12x, and then negative 6 squared is 36. I can do the same thing on b. What's the value for a, for example, b? 5x. What's the value of b? 3z. Okay? So again, I have a squared plus 2ab plus b squared. So a squared plus 2 times a times b plus b squared. 5x times 5x. 25x squared. 2 times 5 times 3. 30. XZ, good. 30xz. 3x. I'm sorry, 3z. Times 3z. Squared. It's a little cleaner. It's a little cleaner, and it's going to help you significantly later down the line. Being able to recognize a perfect square trinomial. Being able to recognize a perfect square trinomial. Guys having fun here? This couple of you are having fun. I'm having fun. Yeah.
It's not like related to this, like kind of like that related.
Okay.
So the square of this, right? Like it's asking.
Alright. Shortcuts. I have the sum and difference. I have the product of a sum and difference of two terms. I have x minus 2 and x plus 2. The same two terms, one being added, one being subtracted. Okay? My rule says that a plus b and a minus b always equals a squared minus b squared. Okay? So if I square x and I square 2, that's what's going to end up equaling, right? Let's prove it. X minus 2 times x plus 2. We do our distributive property. X times x gives me x squared. X times 2 gives me 2x. Negative 2 times x gives me negative 2x. And then negative 4. What happens with these two terms? So what am I left with? X squared minus 4. Okay? So noticing the product of a sum and difference of two terms gives us a difference of squares. Speeds up the process. So now, what I have, when I multiply these two together, I still have this other x squared minus 4. So you could go through and you could distribute again. Okay? But notice now that we have a binomial squared, I had the same thing, right? I had the same thing twice. So then I could use my binomial squared shortcut, which was a squared plus 2ab plus b squared. What's my value for a? X squared. So x squared is my value for a. What's my value for b? 4. Negative 4. And then we can simplify it. What's x squared squared? X squared squared. X to the 4. 2 times negative 4 times x squared. 8x squared. Good. Good, good, good. And then negative 4 squared. Well, no, not negative 16. Positive 16. Negative 4 is being squared. So the negative is part of it, so positive 16. So ignoring this part, where I was just kind of doing a proof, you could sit here and you could distribute all of that, combine like terms, simplify, but if you know the special cases, it streamlines the process significantly. Okay? Streamlines the process significantly, allowing us to save some time. And again, the payoff for this, for factoring, is significant. Okay? I would say that the factoring unit is always kind of the biggest grind. Practice and repetition, really proficient at it. So the more you invest in knowing these special cases now, the more it's going to pay off later. Okay? So here, right, I have x squared minus 4 twice, right? Multiplying it by itself, so it's that, which falls under this special case. So I can use this special rule for expanding it. Instead of, if you want, you can distribute. You'll get the same thing. But by using this special case, and a is x squared and b is negative 4, we can just drop those in and simplify. All right, real quick. Last one. Composition. All right, f of x is this, and I want to find f of a plus 3. So whenever I have this, this is my value of x, right? So I'm going to replace x with a plus 3. A plus 3 squared plus 3, a plus 3 minus 4. You would square that, distribute, combine like terms, and we're done. You're distributing the 3. You'll square first, then distribute the 2, and then combine like terms. Bye. Have a good day. Yes.
To go in calculus class, we have to do pre-calculus the
Yes.
last year. Okay, so next year I cannot go to calculus.
Correct. You have to take pre-calculus first.